Assalamu alaikum students. We are having the lectures for mathematical tools and today our topic will be differentiation of exponential functions by Abnishu. So let's take some function. We are having function y equals to e raised power x. It's an exponential function. Let's differentiate it. Name this equation first. So the method will be same, giving small increments on both sides. Small increments on both sides. Once you will give small increments, then y will become as usual y plus delta y, but the increment is to x, as we have already written it, not here but already you are aware that we are actually giving small increments on both sides. We then write delta x to x and delta y to y. So this y is going to become y plus delta y. Then we're having e raised to power x plus delta x. Now as usual we have to proceed. Then delta y comes out to be e raised power x plus delta x minus y. So using the value from equation first, what we'll get? So we will get delta y equals to e raised power x plus delta x minus e raised power x. Or I can put it like this: delta y equals to e raised power x into e raised power delta x minus e raised power x. Here I have solved this way term. Here I can put it once bases are same, powers will be added, so we will get this very term. Then we can proceed like this. This will be delta y equals to how much? Here it is e raised power x, here it is e raised power x. Just take e raised power x common, it will be e raised power x, and within it you will be with e raised power delta x minus 1. Then where having step sinus increments are sinus increments are very small, so take limits on both sides. Once we'll take limits on since for the first step that we have to divide both sides, dividing both sides by delta x, then we can take limits. We cannot take limits first. It will be delta y by delta x equals to e raised power x into e raised power delta x minus 1 divided by delta x. Now we can write it down like this: as increments are very small, so take limits on both sides. So once we will take limits on both sides, what will it become as? It will be limit of delta x tends to 0 delta x tends to 0 e raised power x e raised power delta x minus 1 by delta x. So in maths this is written as dy by dx, and this we can put it as we can put it like this: e raised power, we can put it like this, limit of delta x tends to 0 e raised power x into, because they are in multiplication tool, you just watch it out, limit of delta x tends to 0 e raised power delta x minus 1 by delta x. If somebody is having a chaos or confusion why I have written twice the limit, I can put it so many times because there is a multiplication, or if sometimes there is division, I can give it separately to numerator, separately to denominator. But e raised power x is in multiplication to e raised power delta x minus 1 by delta x. So I can put it, if there are so many terms in addition or subtraction, I can give separately the limit term to each of them. So now it becomes as dy by dx equals to, this is limit of delta x tends to 0 e raised power x. In this one becomes as 1. This is simply 1 because we are having the limit of x tends to 0 e raised power x minus 1 by x equals to 1. From that we can conclude that e raised power, instead of x we are having here delta x delta x. There is delta x here, it is x x and x. This equals to 1, so this equals to 1. Therefore d by dx of, instead of y, yeah, first we will write y is simply e raised power x because there is no delta x in it, or you have to say it is therefore d by dx of, instead of y we were having e raised power x, we will get what, e raised power x. So the differentiation of this very exponential function e raised power x is the function whose differentiation is same as that of the given function.